There we go. All right, thank you very much, guys. I'm very, very happy to be here in my second time in your beautiful city, Bangalore, and India. I don't know if you guys, how many of you have been here for the first time? Okay, wow, more than half of you. Excellent, this is what I want to see. So the talk for today that I have for you is more like an introduction on different JVM languages. So before we get into the matter, does somebody recognize the subtitle that I have on the back? Somebody recognize the movie reference? Dr. Strangelove. If you haven't seen that one, it's kind of like a funky Stanley Kubrick movie. Highly recommended. Anyway, so that's the whole point. When we are faced with learning a new language, we always get some, I don't know, at least myself, I got a little bit scared of, is the syntax so different? How I'm going to do this where I'm already used to do that on my other language? So the whole point is to stop worrying about these things. So syntax is perhaps the first hurdle, but it's the first obstacle, but it's really just that. It's just a tiny obstacle. What really matters is what comes after, what you can actually do with the other language features. Okay, so I promise this is the only boring slide I have myself. I already have been introduced, so this is pretty much it. I come from Mexico. That's why I wear this pin. But I'm currently living in Switzerland, working for a company called Canoe. And I love the Groovy. I must say that already. Groovy is one of the languages that we're going to see here. So I will try to be as impartial as possible. But if you see me leaning towards Groovy and you don't like it, just tell me to go back into the center. All right, so that's it. Okay, some facts about Java. You may know this already. The first name was Oak. And the reason why it was named Oak is that Jase Gosling had a beautiful oak tree outside of his office. He needed to pick a name, and they said, oh, what a beautiful tree. So let's use that one. Then the project evolved into something that was close to a Smalltalk. As a matter of fact, Java has a lot of Smalltalk roots. And then it became known as Project Green Talk. And had a funky robot as a mascot. And for some reason, they decided to rename it Java just before their release. And now we got Duke, which nobody actually knows what Duke is supposed to be, but it's a funky little guy. So it made its appearances, the public one, in '95. But it was actually began working around '93. And what's interesting is that the latest trend, so everybody, I guess, have heard so far of the Internet of Things, right? All devices should be connected. If all devices share data, then we should be able to do more stuff and eventually be happy with the stuff that we have. Well, it turns out that the original approach, or the original focus of the Oak language was to do precisely this. So what happened? Well, applets happened. And then server development happened. So Java had a big push into the server side, and I guess most of you work on the server side. And now we have a resurgence of Java back into mobile spaces and devices and whatnot. So it's great to see Java going back to its roots. And let's see, with every iteration the language does, let's see how far we can go. By the time that Java was designed, everybody that wanted to do something out there, to be productive in some way, use C or C++. Anybody here that still code with those languages? Yeah, a few. Okay. Semiconductors related, maybe? Embedded devices? All right. So the creators of the language needed a vehicle in order to make this new language be accessible to the huge number of developers that already had great expertise with C and C++. This is the reason why the Java syntax is so close to C. And they decided to take some things away, for example, pointers, even though we still have null pointer reference and null pointer exceptions out there. But it's easy to migrate from the old days to Java. Another interesting thing that happened is that the language brought, at the time, new constructs or something that were kind of like very modern. So networking. You had to use external libraries from C in order to be able to create a simple client-server application. Now threading, ooh, there were so many different threading libraries. And one of the problems with threading and C is that, yeah, it works on my machine. Now push it to another machine with a different platform and who knows what's going to happen. So Java made these things more standard, more easy to use. And developers just came for the applets. Do you remember the applets? Do you remember the Duke dancing around, doing the tumbles? Yes? We wanted to create applications with animations on the web. So anybody remember Netscape 2? This is the time where the applets got into the scene. Okay, and what happened with applets? They're kind of gone. They're actually still there, but they never catch on. What actually catch on was Java on the server. Perhaps some Java on the desktop, but mostly on the server. So I venture, I guess, that most of you work on the server side, isn't true? Yeah, exactly. And only a few make desktop applications, RCP technology, something like that. Yeah, that's what I expected. So, what are a few of the problems with Java? Well, it was started in '93. We're already 2015, so it's no longer a teen. It has grown out of a teenager. Now, some of you are parents. We all were teenagers. We know how teenagers behave, right? They are difficult to deal with. And Java, the language, kind of is still in that area. Now, it didn't actually have any groundbreaking features added to the language prior to Java 8. So when we had the latest big addition to the language was back in 2004 with generics, with variable arguments. Well, the assert keyword was added in Java 4. And, well, JDK 6 came a little bit late. JDK 7 came 4 years later. And nothing happened. And then JDK 8 came out last year, and instead of 2 years ago. And it added, finally, Lambda expression support. So as you see, the evolution of the language, it was kind of fast at the beginning, and it has slowed down, or it had a period of quietness. And now it starts to pick up the pace again. We're hoping that JDK 9 will give us modules with Jigsaw, some other additions in Project Coin. And if that is the case, well, I'm really hoping to get very surprised with what JDK 10 will bring. Sadly, one of the realities that we face in our organizations is we are not that fast to get into the latest releases. For just a quick taste, who uses JDK 8 already in production? See, just a few hands. Who has switched to JDK 7? Okay, half of you. Who's still running JDK 6? Few hands. JDK 5? Okay, I just helped migrate a customer from JDK 4.2 to JDK 6 because JDK 7 was still risky. So if you haven't migrated to JDK 8, please do it as soon as possible. JDK 7 has already marked as end of life. You want support for that? You have to give some. Otherwise, just go to 8. Believe me, it's much better. Now, the language itself, the syntax, is kind of verbose when you compare it to the other options. So who likes to use JavaScript? Or if you not like, at least use it every day. PHP, Ruby, okay, a few, Python. What else? Smalltalk? Do you know you can run the Smalltalk on the JVM? There's a language called Redline. That's funny. The threading features that you find in Java itself were good at the time, but as we started adding more cores to our processors, well, it turns out that they were not that good enough. Then we started seeing some additional libraries come up, like actors, or some stuff like software transaction memory, data flow variable, CSP. Now, one of the reasons that we got Lambda expressions in JDK 8 in the language is so that we could express our problems in such a way that is closer to the domain, but also that the processor or the JVM, as a matter of fact, could do some optimizations in terms of parallelization of the code. But we don't have to really massage the code so much in order to make it parallel aware. So I have some questions for you. And you say, is it true or not? is Java often referred as over-engineer? Exactly. See, when we compare with other languages, it's, oh, Java is too many things that you have to do just to print out something to the console. Why? Okay, can you build a Java web application without using an IDE? And be honest about this. Can you use Vim, the best editor that exists? I'm sorry, Emacs guys, but Vim is the one. So who can write a Java web application without the usage of an IDE? But you can if you use PHP or Ruby or something else. So what's going on here? Finally, was Jase Gosling ever treated with bodily harm? That means that somebody was going to beat him to a pulp if he decided to add operator overloading to the language. This was back in when Java 1.1 was about to be released. Yes or no? Turns out that the answer is yes. Because remember the time, we were in C and C++ all over the place. There are so many great features to be found in C++. As a matter of fact, somebody says, well, C++ has 20% of its features are the greatest. Sadly, nobody can agree what that 20% is. And one of the problems was operator overloading. Turns out that he really wanted to have operator overloading, but there were many people against it. We'll see if in the future, maybe JDK 10 or JDK 11, if this feature gets added. I have definitely no inside knowledge of this. I'm just throwing out ideas. But know that there are other JVM languages that exist right now that allow you to have these features. So if you miss operator overloading and you still want to work on the JVM, just have a look at the other languages. So after that, we know that working in the JVM is great. That's why we're here. That's why we like to work with things. Now, but we also know that the language itself, Java, is a little bit difficult. The great thing about Java is that it actually signifies two things. One is the language that we know. Some will love it, some hate it. And the other is the platform. So the better thing that we can find today is the platform itself. It will allow us to run different JVM languages. So what we can do to make these things better is pick one of those languages. As a matter of fact, there are more than 250 different languages that you can choose from in order to work inside the JVM. Granted, some of those JVM languages are just playgrounds or toys or some features. Some other languages are very stable and very mature. So the ones that I'm showing here in these slides are perhaps the most well-known. Some of them fall into the dynamic languages camp. Some others go the static way. And there is at least one that has both sides, both static and both dynamic. So to begin with, Golo is a dynamic language that targets only JDK 7. It makes extensive use of JSR 292, which is the JSR that added a new JVM instruction, invoke dynamic. JRuby, the latest editions, make use of this invoke dynamic feature in order to make really fast the language. As a matter of fact, for those of you that love Ruby, JRuby is faster than CRuby. This is something that really, really makes mad the hardcore people from Ruby. How can it be possible that Java, that has a runtime environment that is supposed to be interpreted, that is supposed to be slow, is even faster than standard Ruby? Well, it is. We have Jython, which is another external language that has been brought into the JVM. And then we got Groovy, Scala, and Clojure, whether you like dynamic or static or Lisp, which is exactly what Clojure is. Or if you want to kind of like a DSL, Ruby-based DSL for writing Java bytecode, that is exactly Mira. You write something that looks like Ruby code, but the output is actually Java bytecode. Or Ceylon, which is more static than dynamic, or even Project Kotlin from JetBrains. In this talk, I'm going to focus in these three languages, because otherwise it will take me like 3 or 4 hours to talk about all of the ones. Besides, these three are perhaps the ones that are more mature, have extensive documentation, have a good ecosystem of projects built around them, and have the most traction on the enterprise. So this is not, I'm going to bash the other languages talk. So don't expect that. The first thing that we want to look at is reduced verbosity. Again, so we're going to start with the syntax, and then we will move on to other features. So we know this from our daily work. How do you create a Java bean? Well, it's just following a set of naming conventions, right? We know this by heart. It's so easy to understand that our IDEs can generate the boilerplate code. Okay? No, I expect no surprises here. Who already uses Groovy? Just a few hands. Okay, watch this. The Groovy equivalent of this code, blink or you miss it. Did you see the change? There it goes again. Java, Groovy. So the Groovy syntax is 95% compatible with the Java syntax. And here is the main takeaway that you can take home from this talk. You started this talk by knowing one language, Java. Now you know another one, Groovy. You can get out of this talk and start writing Groovy. No, I'm not joking. No, it's true. Rename your .java files into .groovy files, pass it through the Groovy compiler, and it's most likely it's going to work most of the times. As simple as that. But if this were all that Groovy can offer you, what's the point of using the language, isn't it? Let me show you a more idiomatic version of this being using Groovy. There you go. Everything is public. If you don't need to specify, but why do we have to specify public every single time? Why don't we make it the default, right? We have longed for property support in Java. We're still not going to get it. We're not going to get it for JDK 9, maybe JDK 10, we'll see. Groovy has property support. Just follow a naming convention, and that code actually generates getters and setters on the bytecode. It's exactly equivalent to this thing. It's much better to read, isn't it? Well, it turns out that, well, Groovy is a dynamic language. If you don't like dynamic languages, let's go into the static way. Here's the Scala version. Actually, there are two. The first one is the Scala idiomatic version. It will generate a Scala getter and a Scala setter and a constructor for this class, following its conventions. And the second one uses as annotation that generates still the Scala conventions, but also generates the Java beans conventions. So because of this, you can write your Java beans, or the pogos, in Groovy will be pogos, in Scala will be posers, like this, and it'll make your code much more readable than before. Now, Clojure is a descendant of Lisp, and as Lisp, the code looks exactly the same. As a matter of fact, there is only one difference with Clojure and Lisp. It uses square brackets for defining the arguments of a function. And that's the only reason why the Lisp purists would say, Clojure is not Lisp. Let me show you that. There is. Being a dynamic language, you only need to define a structure that contains all the attributes or properties that you need. You give it a name. It could be bean. And who cares about the type? If you need a type, you will specify it. Otherwise, just leave it out. In this case, we're just saying it needs a property called name. That's it. Good. So far, so good? If you have any questions, just let me know at any time. Let's see. Closures and functions. Well, I think I should have updated this one. Prior to JDK 8, the only option that we have for simulating embedded expressions or something that looked like closures or functions were anonymous inner classes. As a matter of fact, the creators of Java said anonymous inner classes were a half step from adding real closures to the language. But for some reason or another, they couldn't make it right at the time. They had other features to be finished before this. I think inner closures were other annotations like this. Sorry, inner classes were added in between JDK 1.1 or JDK 1.2, which is a long time ago. So they had to figure out something else to do. So now we know, well, this is what we used to do, implementing a functional interface. Now we know we can use lambda expressions. But in Groovy, well, this were some of the proposals for JDK 8.7 first, that were later pushed to JDK 8. The first two, notice that we still had to define those types and that will be the body of the expression. There was another one that will use the, how do you call that? Pound, sharp, octotharp? Hash. If you use hash, there is a funny joke about that and Unix. I will tell you that later. So this will be it. That you had to have explicit return keyword, and even though it was a very basic expression, you had to use the semicolon and the curly braces, yada, yada, yada. Good thing is that when you only have a single line expression, you can use this in JDK 8. That is very close to what you can write both in Scala and Groovy. Let me show you the Groovy version of the same function. If you don't care about types, don't use them. If you do care about types, put them there. I'm just saying I need 2 arguments, whatever they are. And I am applying the plus operator on it. Good. I'm saving that as a reference to a function. The name of the reference is other. Now I can pass other anywhere I need it to. This is the Scala equivalent. You define the inputs. In this case, you do have to define the types because I'm defining a standalone function. If I were to define an inline function, it's very likely that the types can be omitted because the Scala compiler does a great job of type inference. So in this case, they use the fat arrow, which by the time JDK 8 was going to use the fat arrow, I really love the idea that they chose the thin arrow. And the body is if a single expression, then there's nothing else that needs to be done. The return keyword is also optional. If it were to be more method or more sentences in the whole method, then you have to put braces and more stuff. And then we pass this as an immutable reference to this function name, and that's it. Now we can pass along that function wherever we want. Now the Clojure alternative, well, we said that Clojure is Lisp. Lisp is functional by default. There's nothing else that cannot be functional in Lisp. So there you go. Again, the only difference that you have with standard Lisp is the usage of square brackets for defining the arguments. Everything else is exactly the same. So if you like Lisp, then you know that you can run it on the JVM using Clojure, as is. So far, so good? OK. Here's another thing. Enhanced switch. I know in JDK 7 we got a new version of the enhanced switch. Well, you can now switch of strings, right? But what if we wanted to do something like this? We want to match a value if it fits within within 2 limits, right? And if that's the case, then we do something. If not, then we go to the next set of limits and we do the same thing. So it's kind of like we're working with a range of values. Now in Java, even with the enhanced switch that we got in JDK 7, we cannot do that. What we have to do is this, a series of ifs. And if there is not a match, we will most likely throw out an exception that, hey, we got something that is not what we were expecting. And another thing here is that in this case, at least the type is very explicit. It has to be an int, right? Let me show you a groovier version of this thing. Go. Now, first thing is, I didn't define the type, which means the value could be anything that can be sent to this method. All right. Then I switch on that one. And then I have some cases. From 90 to 100. That, what you see there with the 2 dots, is a new data type that Groovy enables. That is a range. You have int ranges, float ranges, double ranges, dead ranges. You can create your own ranges. As long as you have a next and a previous method, it's easy to do this. So if the value grade, whatever it is, it happens to be a number, and that number falls within the first case, then you're going to return the character A. You follow the other cases, it's quite the same. This will say between 80 and 90, but not 90, so it's exclusive 90. It goes to the NT9. Fine. What is that thing like? Looks like a string, isn't it? Sorry? It is a regular expression because of that character right there, the tilde. Another thing that we got in Java 4 was regular expressions. But just answer me honestly. Do you like working with Java regular expressions in Java? They're kind of a pain. Yes, especially escaping the characters. Well, I have good news for you. Groovy has first-class citizen support for regular expressions. You don't need to do double backslash escape this and that, force back that. No. Believe me, it's much, much simpler to do those regular expressions in Groovy. In this case, what we're saying is, wherever this thing is, if it matches within that regular expression, then that thing is most likely a string or some string char sequence. So what I'm going to call is the method to uppercase on that. Maybe if you want to be safer, you wrap that into a string value of, and then call to uppercase if you want. But chances are this will work all the time. If nothing matches, then we just throw an exception as the previous case. Let me show you the Scala version. It's also very terse. What you see in the first line is the usage of a library. Scala comes with its own collection library, which is a mirror of the Java library. And when you need to consume Java collections into a Scala, sometimes you need to have a translator within these two worlds. But that's just usually it's a minor thing because the translation from back and forth is quite simple. So what we have here is a set of strings, some final values, immutable. And then we have this function that takes any value. This could be anything. So in Java, the base superclass of everything is Java-lang object. In Scala is any. And this function returns a string. Okay, and now we do something that looks quite weird. We're calling a method named match on a value, this thing. And inside those braces, we apply our cases. The first case is whatever x is, in this case will be the value that we're matching, it has to be an int. If it happens to be an int, and if it's between 90 and 100, then you return that value. And then you continue going with those things until we find the case of the regular expression. Well, that's actually not a regular expression, they're just matching. If the type is a string, and we hope that it only contains one character, and that character is inside the set of strings that we defined before, then we're good to go. Perhaps what I missed here is I'm not throwing an exception and also not showing the regular expression support that Scala has, which is also top-notch. Finally, the Clojure version. We define a function that takes an argument, again, dynamic. Now we apply a condition, and if it happens to be within this range, then the result is that. So we follow, and then we apply another function that deals with regular expressions. If the grade falls within this expression, what we do is we call the method to uppercase on that object. So the difference for those that, I guess most of you remember lists from college, what you actually call is first the message and then the receiver. So far so good? All right. So let's see what I have. Interoperability with Java. Groovy and Java can talk to each other as is. There are no need for any special bridges. The same is true for Scala and Clojure. So Scala can load a Java class or Groovy class and vice versa as if it were written in the native language. The same goes with Clojure. Clojure can consume everything, and you can generate classes with Clojure that can be consumed from Java or the other guys. This means that every single library, every single framework that you have access to today with just plain Java, you can combine them with these languages. There is no need for, when was it? JDK 5, between 5 and 6 if I'm not mistaken. Definitely 6, JSR 223, which is the scripting languages JSR. It provides a scripting engine for you to load Python, JavaScript, Groovy, many others. No need to use it, really. Don't go with JSR 223 in order to load Groovy or the other guys. Just use them directly. For other languages, you might need to use JSR 223. So what else can these languages do? Well, all of them have pretty much native syntax for collection classes. The collection literals for Groovy, I didn't show that, but I showed the one from Scala. And well, lists in Lisp are pretty much what you use every single day. Hashes, and I guess you don't have sets. Everything in these languages is an object. So even though I showed an int in the Groovy code previously, that int is actually wrapped into Java-like integer. So you can call methods on that. So even though you see a number on Groovy, you can call a method on that number. As at the beginning, I know it starts to look weird. You can actually do the same thing in Scala. We have closures, all of them. Well, now JDK8 has closures, so maybe this is not such a novelty now. And all of them have good support for regular expressions. Now, in the case of Groovy, I think this is the feature that sold me the language. It's not just that I will be able to write much terse code or that is more condensed, is more expressive. It's the fact that I have metaprogramming at my fingertips. Metaprogramming is the capability of a program to change itself. It may be scary at first that you can add properties, add methods, or remove properties or methods, create a new class out of the fly, on the fly, out of thin air. Really, you can do this, and there are reasons to do so. And this is a great thing to do, but it also brings a lot of responsibility. In Groovy, you have runtime metaprogramming, which was the original one, and then later in Groovy 1.6, we added compile time metaprogramming. The great thing about compile time is that all those new changes that you add to your classes are put into the bytecode, so they are visible to other languages. Runtime metaprogramming is only visible to the Groovy runtime. Groovy has operator overloading. Yay! And it has a healthy ecosystem of many projects. You probably have heard some of them already. Grails, Gradle, Griffon, Spog, Jeff. We had talks about these topics on this conference. As a matter of fact, after this talk, I have another one on Griffon. If you're into desktop application development, I seriously encourage you to have a look at this one. And this is definitely not an exclusive set of features. I would say that Groovy has reached a good number of features. It actually may have a little bit of overload in terms of features. It's definitely not a very simple language, but it's not a very complex one. It's kind of like in the middle, leaning towards a little bit to the complex side. Scala. It definitely has a much richer type system. One of the first things that you encounter with people that love Scala is that they say, if I can reason my problem in terms of the type system, then I'll be able to put that into code, and I'll be sure that these things work. This is a boon and a bad thing to have in the language, because many people believe this to be a good thing to have. The type system catches all my errors. The compiler does all the work, so I don't write any tests. If you were at yesterday's keynote by Scott, you know that the compiler will not be able to catch some of the problems that are semantically based. So as good as the type system it is not the only thing that you should rely on. You should always create tests. Now, it also has, the creators of the language said that Scala is kind of like is the first one of a new breed of languages. It is a mixture of functional and object-oriented. You can argue that, yes, you can do functional in Java, but it's not as rich as you can do it in Scala. Yeah, you can do functional in Groovy too. It is also object-oriented, but Scala gives you much more than that. It has first-class function types for that. It has type inference. It has pattern matching, as we saw before with the match method. It has an actor model for dealing with concurrency, and now I should say, for years, the Scala community has said that actors are the solution to your concurrency problems. Let me go on record and say they were selling you something that is not true. Actors are one of the options that you have to solve your concurrency problems. But it's, as everybody else and everything else, is not the silver bullet. There are more things that you have options. You can create your own operators. As a matter of fact, operator overloading in Scala, you can go crazy with ASCII art operators. There are reasons to do so. And it also has traits. Groovy has traits too. Clojure, the great thing about Clojure is that the way that you write your code is the same way as you write your data. So it's a homoiconic language. It brought immutable structures, which were later copied by other languages, which means that once you create an instance of an immutable structure, you want to mutate the contents of that one, you have to do it inside a special block. If you do not, you get a problem. You cannot do it. It also brought us software transaction memory that pretty much works like in database transactions. So you try an operation to mutate something. It fails, don't worry. You roll back and then try it again. So this is basically STM. And now I'm going to show you a small application with some of these languages working together. Let's see. I'm going to switch to the IDE. This is, just for the sake of demonstration, this is a desktop application just because it makes it easy to consume things. It is a Gradle project. So what we have here, I'll show you quickly. What we want to have is different implementations of this interface. This is a plain Java interface that defines a single method. So kind of like a functional interface. We could have added more, but just one method will suffice. Takes two doubles, returns a double. We assume that this thing will apply the summation operator on these two. Perfect. So the straightforward implementation of Java, this one, right? Not so difficult. Okay, let's see the Groovy version of that one. The public modifier is gone, return keyword is gone, but it looks a lot like the Java one, right? Not so much different. Then let's go with the Scala one. There we go. Do you notice something interesting in the definition of the Scala calculator? The extends keyword, right? In Java, what do we do with interfaces? We implement interfaces. But in the case of Scala, you can extend an interface. And we have to explicitly say we are overriding. In the case of Java and Groovy, you use an annotation. In Scala, you do have a keyword saying, I definitely need to override this method. And you define the types. Another interesting thing is that this double here is not a Java lang double. It's an Scala double. So a Scala will automatically translate your Java types, your Java base types, into Scala base types, and vice versa. If there are other types, for example, the Java collections, you do need to make those transformations explicit. Unless you use a feature in the Scala called implicits, where you give some hints to the compiler regarding some additional classes that you can use as bridges within one type and the other. Finally, let me show you the Clojure version. We define a namespace that will hold our functions. Then we use a macro that says gen class that implements the interface that we need. And then we define functions in this namespace. And we have to be sure that we follow the main convention. It has to be the name of the method that we want to override, but it also has to have a dash at the beginning. If we don't use the dash, then the method will not be implemented, and that will be a problem. And notice that we're just using plain Clojure here. We define the arguments, and then we use the plus function or the plus operator, and then give it the two arguments. That's it. All right? So I do have all these classes except the Clojure one. I was not able to set it up with Gradle so easily. The compiler didn't work as I expected. So this Groovy code will load all these classes, the Java one, the Groovy class, and the Scala class. And we'll put everything in a nice UI when I can enter inputs and outputs. So I'm going to run that class, that application right now. Let's do a clean. I'm going to make this bigger so that you know that I'm actually compiling code. That's good enough. Gradle, clean, run. Okay, so it's checking the configuration, compiles Java, compiles Groovy, compiles Scala, and then launches the application. And sadly, it's a little bit small. Can I make this zoom? No, sadly, no. Does anybody know the shortcut for zooming on OS X? No? Should learn that one. Anyway, so the Java version should work easily. Let's say 1 plus 2 should be 3 as a double. I don't know if you can see that's 3. Then the Groovy code 3 plus 4 equals 7, 7.0. And then the Scala code, 5 plus 6 equals 11. And we can change that to 5, and then now it will be 10. So basically, what we have done with this project is make sure that we got all our classes in the right place, following the conventions on Gradle. Your Groovy code goes into source main Groovy. Your Java code goes into source main Java. Then your Scala code goes into source main Scala, and Clojure code goes into source main Clojure. You enable all the compiler plugins for the build tool. Everything compiles, gets put into the class path, and off we go. I can show you the classes were actually compiled. Build classes main. And there we see the calculator interface, the Groovy calculator, Java, and the Scala calculator. Again, I said that the Clojure plugin was not configured correctly, so it's not generating the classes. But if I had configured it correctly, then we will be able to use that thing. So what I'm not proposing to you that you make use of all these languages in the same project. This is just a tiny demonstration that you can use for, well, yeah, if I had used Clojure, 4 languages within the same application, and it's not really that difficult. Okay. What about these ones? Well, Clojure, Scala, and Groovy have lots of information, a lot of documentations, a lot of developers out there in the world already making use of these projects in production. Golo and the other guys are kind of like newcomers, the upstarts. I will definitely keep an eye on these ones because they will make the news very, very soon. Ceylon went 1-0 a year ago or so at Davos, Belgium. Kotlin is not yet 1-0, but is very, very close. Interestingly enough, both Ceylon and Kotlin follow an approach of giving you something that looks like Groovy, but has the type safety of Scala, plus other features. Golo is fully dynamic, and Mira, again, is just like a Ruby DSL. You write Ruby code, but eventually you get Java bytecode. I could have written a Mira calculator for this project too, but then I would have to hook in the Mira compiler because I don't believe there is a Mira Gradle plugin. If there isn't, somebody ought to create that one. Also, have a look at this guy. Does somebody recognize this logo? It is Nashorn. This is the second implementation of JavaScript running in JVM. The first one is Rhino from Mozilla. The second is Nashorn from Oracle, which is very fast. And Oracle is pushing JavaScript on the JVM a lot. It makes sense, of course. Everybody is going for Node these days and JavaScript. So why not bring those developers back into the JVM? Keep an eye on Nashorn because the speed improvements that they're going to put into the language and the JVM are going to be dramatical. There are other places where you will find Polyglot Programming, believe it or not. It's not just the JVM. How many of you are web developers? Half. So you use HTML, right? XML, JSON, CSS, less something else. Well, guess what? You're doing Polyglot Programming. Yes, you're not using just one language. You're actually using a mixture of different things to create a single application. So it's kind of like silly to think that just because we're writing this on the server side, my logic is in Java or the other guys, then I'm not doing Polyglot Programming. No, as a matter of fact, we all are doing Polyglot Programming the moment that we're using at least 2 different languages. Well, Flex is kind of dead now. There are some people still writing Flex applications out there. Yeah? I thought so. Why, sorry? The question is, why do I say that Flex is dead? Well, easily. The guys that created the platform simply said, we're not going to put more releases of this, so you're on your own.
No, they thought that HTML5 and CSS2 will kill them, but actually they were too good. Personal experience in working in product.
Yeah, so the question is, HTML5 and CSS were supposed to kill Flex. Personally, I used to work with the previous ones, just Flash. And there were some memory leaks issues with the platform itself. Yeah, eventually it was much, much better, but the company decided to say, we're not going to further invest in this thing, so now we have to choose other thought. Oh, let's see that, shiny, Silverlight. Who uses Silverlight now? Huh? What did Microsoft say about Silverlight? Same way. Okay, next-gen data stores. I used to have FleetDB here. Now it is another one called Atomic, which is written in Clojure. There are banks in the United States that use Atomic and Clojure as part of the core business. So if you see, if these banks, which, you know, in the US, they're crazy about money. If they are able to risk the whole business into something that looks new or lispy, then definitely our startups, our companies can use of Clojure too. FlockDB was written in Scala. I'm not so sure if it's actually still in use. It was written by Twitter in order to be able to consume all the data that they have about the followers and the users and whatnot. CouchDB and Ryak, they are big in the NoSQL arena. They are written in Erlang, not even in the JVM. Watch out for polyglot persistence. What this means is a mixture of SQL, NoSQL, whether that means I don't use SQL or not only SQL or new SQL or whatever SQL you want to call it, it is already here. You also find polyglot programming in different build tools. Gradle is perhaps the best choice, I will say. There is also another tool called Gantt, which is a Groovy version of Ant. Take away the ugly XML, put a nice coating of Groovy DSL. That's Gantt for you. Rake, if you're running Ruby or JRuby. Maven 3, if you like XML. And Maven 3, there is a recent version called Polyglot Maven. What it does is that it takes away the XML, allows you to use a different DSL, Ruby-based or Groovy-based or something else, and you get the same model. SBT stands for something that is not true. It's not the simple build tool. It's something else, which I don't know, but it's definitely not simple. But that is the build tool of choice for Scala projects. And Leiningen, that is the build tool written in Clojure. The things about these tools is that, for example, in Leiningen, you write Clojure code, and that is your build file. In SBT, you write a Scala code, and that is your build file. In the case of Gradle, you write a Groovy code, and that is your build file. I think we're pretty much close to finishing this talk. So I hope that I have given you some hints, some ideas of stuff and languages to try out. Again, just give it a try. If it doesn't work for you, no matter. Go with the next one. Perhaps you will find something. Maybe you will say to me, Andres, these languages are great. It's excellent that they run on the JVM. However, my company does not allow me to use a language that is not Java. It is not sanctioned by the high multi architects. What can we do? Try those languages still. Use them on your free time, because chances are that you will find a feature in one of these languages that will make you think about the solution for a problem in a different way. And then you will apply some of these things in Java. Maybe you can simulate one of those features in Java itself. But most importantly, it will make you think about the solution with a different perspective. So play around with them. I have some, I don't know if it's visible enough. Those are the three main ones that we showed. Groovy-lang, Scala-lang. Sadly, Clojure doesn't have a Clojure-lang website, but it's right there, clojure.org. Excellent documentation for the three of them. Plenty of information out there to learn from. There are books, talks at conferences, training, you name it. It's very easy to get into these three languages. If you want more details on the other ones, here are the URLs for all of them. So Kotlin, Ceylon, JRuby, Mira, Python, and Golo. Finally, some of the information that I presented to you today was taken from a good friend of mine, Stuart Holloway, in, I think it was 4 or 5 years ago. He was trying to reinvent his company. And he was looking for what was to be called next-gen Java, or Java Next. So he started a series of blog posts exploring these languages. At the time, it was JRuby, Scala, Groovy, and Clojure only. And he ended up going with Clojure. So if you want to know more about the background of why he decided to go with Clojure and what was he doing at the time with these other languages, just go to that URL. And if you're interested to learn more about the desktop application that I showed today, well, the name of the framework is Griffon, and that's where you can find it. So right now, we still have some time for questions. And if you have them, then I'll be very happy to answer them. There's a gentleman, a couple of questions here on the front.
Hi. I think your runtime was still Java. What's your, and I understand you compile jars, like everything into one jar. What's your views on, what the runtime should be? Should it be Groovy runtime? Maybe the Scala and Clojure have different runtimes, the binaries and all. So what's your views on the runtime?
Okay, so the question is about the runtimes. And that is a very good question regarding Mira. So Clojure, Groovy, JRuby, Scala, Python, Ceylon, Kotlin, all of them provide compile time libraries and runtime libraries that you need to put on the class path. Mira is the only one that doesn't have a runtime library because it outputs everything to Java bytecode, so it can consume any Java library out there. As a matter of fact, you can consume Groovy from Mira without any problem. So the only thing that you need to take care of is that you use the right runtime for the particular language that you're using. There are some rough edges in the different Groovy versions. When you switch from Groovy 1.7 to 1.8, the runtime has an incompatibility. When you switch from 1.8 to 2.0, it has another incompatibility. From going to 0 to upward, they're exactly the same. Why? Because these versions should have actually been major breakthroughs, but they were labeled as smaller ones. Scala, for a while, used to break every single runtime release. Now has gotten better. And in the case of Clojure, I think they've been able to keep the compatibility much in line.
Yeah, one question, this side.
Yeah. Is there any best practices in terms of, profiling these codes for memory and the memory consumption and runtime and other issues which could happen because the language abstracts out a lot of things?
Right. So in terms of profiling, I have good news for you. Because all these languages, most of them compile to Java bytecode, you can use the standard Java tools that you already know, which means you can use any Java debuggers, any Java profilers as is. Some of these languages will have longer stack traces, or even when you put a breakpoint in one place, once you start stepping through, you will see that the breakpoints go into different places until it actually reaches your production code. That is because in the case of Groovy, for example, there is this thing called the meta object protocol, which is what enables you to do the dynamic method dispatch. So there is some additional machinery and plumbing that needs to go through for the method to be dispatched. In the case of Scala, depending on if implicit or not, then your code may go somewhere else and then come back into production code. So besides that, you should be able to use any standard Java tools with any other languages. And of course, tooling, a specific tooling for these languages is getting better and better. Eventually, we hope it's going to be as good as we have right now with Java language.
Yeah. This side. One question about what you mentioned about the code and the data being interchangeably programmed. So from the Lisp days. From
Clojure.
So now Clojure and Scala. So my question is, for a use case of a machine learning, where I have a capability to change my code itself on runtime. So not even adding a function or method or deleting a method. Is it possible to change the logic itself, like polymorphism, which happens in pure C++? So the if structure I modify. So is it possible that instead of methods being added or deleted, the if then else also getting modified depending on the runtime? And which is a particular language which is more suited for machine learning kind of use case?
Well, The first thing that I will say is, where are you running this? Is it in a big computer or is it a small computer?
Maybe laptop.
In a laptop, okay.
Yeah.
Because size is a restriction. If you go as small as possible, then your only option may be Java or Go native, because these languages have additional runtimes, and some of them may require a little bit more memory, right? So that would be the first constraint. But if you're working on a regular computer or even a supercomputer, so these languages are not the bottleneck. So now you look at the features that the language will provide. If its code looks exactly like data, so that you can go back and forth, then maybe Clojure would be better. Okay. Maybe it is the case that the algorithms that you're looking at are better expressed in a list derivative. Again, so Clojure will be the option. Okay. Maybe it's just full functional based. Scala will be an option. Okay. If you really want to go with a program that can change itself at runtime kind of like wildly, I will go with Groovy, which you can do functional also, given some constraints. So be aware of side effects. Oh, I failed to mention, there are any Haskell users here?
Oh, yeah, we used to go in meetups in Bangalore. So Haskell is picking up. The elite is in Scala. I think the shortcomings are not there in Haskell. It's picking up like anything.
Yeah, so I failed to mention, there is a Haskell for the JVM called Frege. Okay. It's almost the same as Haskell. So if you want to copy and paste a Haskell code, a Haskell algorithm, and run it in the JVM, have a look at Frege. F-R-E-G-E.
Okay, thanks.
Just one more question. So why do you think we have 280 odd languages for the JVM? All languages essentially do the same thing. I can understand some of these modern languages, you write much lesser code than you used to write in Java. So, and it's much faster, unnecessarily declaring variables and doing a lot of things, syntax. Agreed that Java may not be the best language for a few things, but then why so many 280? Maybe 5 would have been more than enough, right?
How many natural languages exist in the world?
Okay, so
more than 6,000.
No, but the reason is that people were spread across the globe and they keep moving. But now the world is just one. Everybody has internet and they have access. At least in the programmers are all connected.
Okay, so you remember the verbosity thing. In Java, you had to write a lot of code in order to output something to the...
I agree, like Java may not be the best language, but all the new ones, at least 5 of them which you named, Scala, Clojure, Groovy, Ruby, I think all of them are so similar. At least they can do similar work. Syntactically, they may be different.
Yes, well, because some of these languages will enable you to use certain features that cannot be written for other languages. There are some, especially Scala has a lot of history with experimental features that get added to production features. This is a little bit of ongoing debate whether Scala is really ready for production or is just an academic endeavor. It actually is both. So you have to be very careful to pick which feature do you really want to make use of. And this, again, this is the reason some people like to play with languages, with theory, and eventually that theory makes sense to put into production. And some other people say, this is just the smallest set of features that I'm really comfortable with, and this is all that we want to do. That's exactly Clojure. It's fully functional, it's fully dynamic, nothing more. No metaprogramming, no compile thing, no static things, nothing. So for some people, going dynamic makes sense. For other people, static makes sense. And this is the reason why we keep having these new languages, because you will eventually find that all of these languages fit into a box, bigger or smaller. And once you have reached the limits of the box, you want to break out. There was another question in front.
My question is in continuation with what Sudhir mentioned. What are the business applications and what are the problem scope in which each of these languages should be used? So what we are saying here is that we have a language, Java, which is there, and all these things we can do in Java, but we have these new languages in which we can do the same thing. But my question is what is the domain in which we should select one over the other?
Again, it depends on all your requirements. If you are working with researchers, if your algorithms are very close to a functional base, I will definitely go with Clojure or Scala first. If, on the other side, you want to be very fast at prototyping, then I will go with Groovy. Where type safety is not an issue, by type safety I mean a statically compiled code, which you can do with Groovy, I will definitely go with Groovy. If your team says, there's no way I'm going to touch a dynamic language, then go with Mira or Scala. If it doesn't work, then you have to go with Java or any other statically compiled language, for example, Kotlin or Ceylon. Ceylon gives us other feature that is really nice. It's called union types. You can define a type that is both a list and a map. So anything, anybody that goes inside fits inside. That's really cool, which you don't find in the other languages. So again, it depends, again, in your requirements. I cannot give you a strict recipe to say, go with this one or go with the other one. You actually have to give it a little bit of a try. So,
very quick thing. I think in the testing space and scripting space, Groovy is making very large gains.
Groovy is known as a scripting language, but it's definitely much more than that. It is a full programming language. You can think of Groovy as a dynamic Java with a few other features. But most of the time, for some reason, people think that Groovy is just a scripting, like Ruby or PHP or JavaScript. We're out of time, but I will be very happy to continue answering your questions on the hallway. And if you want to see the other talk, perfect. So again, thank you very much for your time. Hope you enjoy the talk.